To perform the mole balance of a component, we first need to specify the system boundaries. We choose a system volume and perform a mole balance for the component whose concentration we are following. For the reactant A, the mole balance is a molar flow rate of A into the system minus molar flow rate out of the system minus disappearance due to the reaction equals the accumulation of A inside the system. Let us derive the general mole balance for any component. This purple object will be our control volume, or our system. The mole balance of the component I will be molar flow rate of I into the system minus molar flow rate out of the system plus reaction term, which expresses the rate of generation or consumption of the component I due to the chemical reaction. And finally, the accumulation term, expressing the rate of change in number of moles of I in our system. We already clarified the reaction term in our previous video on the reaction rate. The reaction term is simply the product of the reaction volume and the reaction rate of the component I for the systems where the reaction rate is uniform throughout the volume. This is valid for well-mixed systems. For the systems with changing reaction conditions, we need to integrate over the reaction volume. For the reactants, we subtract the reaction term since the concentration of the reactant is depleting. For the products, we add the reaction term. And don't forget to put minus in front of the reaction rate for the reactants. Each term in our mole balance has a unit mole per second, or generally mole per unit time. With the general mole balance, we can develop the design equations for various types of reactors. Upon evaluation of the design equations, we can then determine the time necessary to convert the reactants to the desired degree for batch reactors, or to determine the necessary volume for flow reactors.